I have uploaded all the videos. Okay. Chemical
I
energetics.
haven't checked it yet, but yeah.
Okay. So chemical energetics. Now for chemical energetics, do remember that we are having two types of reaction. One is exothermic reaction and the second one is endothermic reactions. Okay, what is the difference between endo and exothermic reaction?
Exo gives out the heat in the surroundings, right?
Okay, fine. Heat is given out.
And in yes, and in endo it absorbs the heat.
Okay, and endo is when heat is absorbed. Okay,
Right.
heat is absorbed, heat is taken in. Okay, so that means if exo is giving out heat to the surrounding, what will happen to the temperature? Temperature should
It
rise, the
will
temperature
start
should
to
fall.
rise.
Yes, the temperature
It
of
will
that,
increase.
the temperature will rise. And what about this one? What about endothermic reaction? The temperature should,
In the surroundings, it will decrease.
yeah, the
For
temperature
the
drops
object, it will
basically. Yes,
increase.
the temperature drops basically, isn't it? If we have
Right.
placed a thermometer, and the thermometer will show you the reading, drops reading, and over here it will show you the rise reading, isn't it?
Right.
Okay.
Yes.
Now, okay, after this, do remember that we are having basically the type of graphs you have to make. One is for each of them, for exothermic and for endothermic, we are having two types of graph basically. Okay, one graph is what? One graph is called as an energy or reaction profile diagram. Okay, first we will not do that one. That first we will do the other one and then we will do this. Okay, the first one we are going to do is energy level diagram. Let us do with energy level diagram. Okay, if you are doing energy level diagram for an exothermic, do remember that exothermic is always given with, okay, do remember that exothermic is always given with the positive sign, okay? Always it is given with a positive, okay, exothermic is always, sorry, it is given with a negative sign, okay? Always you are having an enthalpy delta H which is equal to a negative sign. Always in exothermic you will be getting a negative sign. Always. Okay.
Right.
So
Yes.
exothermic will give you a negative sign over here. Now, if I want to draw an energy level diagram for the reaction as I am having NaOH plus HCl, that is giving you NaCl plus H2O. So that means this is my reactant and this is my product. So when you are drawing energy level diagram, what you are going to do, you are going to make X and Y axis. Do remember for x-axis, this is your energy. Okay. Now do remember when you are having an exothermic, you are going to write reactant up. Okay. And down over here, you are going to write product. Getting it? So over here,
Right.
as we
Yes.
are having the reactant, I am just writing the reactant, but you are going to write whatever equation you are given out
All right.
in this way. Okay. And after this, do remember that you have to show the enthalpy. This is called as enthalpy. This is called as enthalpy, which is called as delta H. You have to show delta H arrow, which is always from the reactant and it goes always to the product. Getting it?
All right.
Okay.
Yes.
So always whenever you are drawing exothermic reaction energy level diagram, you are going to draw this type of diagram.
Okay, got it.
Okay, got it? So you can make this diagram.
Yes.
Now, along with this, sometime what happened, you are told to draw reaction profile diagram. Okay, there is a big difference in both of them. Whenever you are asked for energy level diagram, you are just drawing, you are just going to show this delta H, you are going to write reactant, and you are going to write product, that's all. You are going to write reaction, you are going to write energy over here, finished. But whenever you are asked to draw in a reaction profile diagram, you have to show the three major points. One is your delta H should be shown. Along with this, what you have to show, you have to show activation energy also. And the activation energy, we write it as EA. Getting it?
Right. Yes.
Okay. So now activation energy for a reaction profile, you have to show an extra thing, which is activation energy. Okay, what is the activation energy basically? Activation energy is, just give me 1 second, I'm just coming.
All right. Yes. Yes, no
Okay,
problem.
so what we were doing basically, we were doing that we are having, when we were doing reaction profile diagram, so we have to add one more thing, which is activation energy. And what is activation energy? Activation energy is the energy or minimum energy. You can write the definition also. The minimum energy required or needed, okay, required for the reactant particles to collide with each other. That means the energy which is required to start the reaction, okay, to collide with
Right.
each other. Okay, so that is called as an activation energy. Okay, so now how you will draw the diagram? Keep the same as we have drawn over here. What you are just going to do, you are going to see the same thing will be drawn. Your reactant will remain on the top, your product will remain at the bottom. In this way, your energy will remain as it is. Okay, your arrow of delta H will remain down as it is. But now what will happen, do remember, whenever you are having an exothermic activation energy, just draw a curve from the top and bring it at the bottom in this way. Getting it?
Oh, okay. Right.
Okay,
Yes.
just make a curve and bring that curve down. Hear me? Hello?
Yes, hello.
Okay. So now what is the difference over here? You will be drawing this thing and you will be writing that this is your activation energy. And do
Right.
remember that activation arrow, activation energy arrow, it is always upward, and your activation arrow for exothermic, extend this line, put an arrow in this way. This is called as this will be your activation energy. Getting it? From the
Yes,
reactant
got it.
side, you are going to extend it, and you are going to write it that this is extend in both ways, and write that this is your activation energy. Done?
Yes, done.
Got it? Understood?
Yes.
What is the difference between both of them? Just the differences of an activation energy. The other things will remain as it is. So instead of
Right.
drawing this product, you can just do it in this way also. Just make this thing, and then you can make this thing. And extend the line and write the activation energy. So delta H is over here. If you don't want to write for an active for reaction, you can write that you have extended the line. On one side, you're writing activation energy. On another side, over here, you can write that this is your delta H. That is on you, doesn't matter. Just we need an arrows. Just we need that curve. That should be correct.
Right.
Okay. Now,
Yes.
moving on to the next one, which is endothermic reaction. Okay, for an endothermic, do remember that our enthalpy delta H will be positive now. Okay, and the same thing, what is going to happen in exo? We were having reactant up. Now we will be having product up. Product on the top, reactant at the bottom. Okay, your energy will be over here. And what and where will be the delta H now?
Will it be on the right
Always
side?
from reactant to product. Always.
Oh, okay.
Okay, this is your delta H. Always from reactant to product, either it is up or down, doesn't matter. So
All
this
right.
what this will be your energy level diagram.
Yes.
Now, if you want to draw reaction profile diagram, what we have to add?
The activation energy.
Yes, we have to add activation energy. And for activation energy, now what we are going to do, same thing. See, this is our product. This is our reactant. Now what you are going to do for an activation energy, you are going to make, okay, now you are going to extend the line. Basically, we have to extend the reactant line. So extend the reactant line because activation energy is always from the reactant to the product, and draw this curve in this way. So now what is going to happen? Your arrow will be, see, your activation energy is from here till here, till the top, basically, this thing. This is your activation energy. So the complete is your activation energy, this thing. Okay? So this complete is your
Yes.
activation energy. And what about your delta H? What is your delta H? Where you will draw the delta H now? It will also be from reactant to product, isn't it?
Right.
So if it is also from the reactant to product, this is your delta H. This is your energy. Getting it?
Yes, got it.
Got it? So see, activation energy is always upward. So over here, see, this is a small thing of activation energy, just a bit of it. Over here, we have started from here, so we are having a long curve. See, basically what happens, I will just draw it again for you. Basically what happened, we should draw this in this way. Then it will be, you have drawn, okay, fine, but I will draw it for you again. See, basically what happened, you are having reactant over here. You will be having product over here. Okay. So now this is your reactant, this is your product. You are starting from here, make it extend, and you are going till here. So this is what, this thing. This is your, this thing. See, this is your activation energy, same thing.
Right.
And same, the same is your delta H enthalpy. Okay, this is how you can draw. Either you can draw in that way, you can draw in this way, that is on you, but better to write reactant over here and product over here. As we did
Yes.
over here. See, we were having reactant over here, we have product over here. So better to do in this way. Okay, product next to the
Okay.
next term. Okay, write product to the next term, it's better. We can change this also, reactant over here and product on this. Got it?
Yes, got it.
Okay, so you got these two. Any difficulty
Yeah.
in these?
No, all clear.
All clear? Okay. Beside this, do remember that we should be familiar with some of the terminologies. The definitions I am going to write, the enthalpy, the definitions I am going to write for you. So all definitions you are going to learn, and I will be asking you this by tomorrow. Okay. Do remember that we are having lattice enthalpy. What is enthalpy? The total amount of energy which is required to make the product from a reactant. Okay. So lattice enthalpy is of two types. Enthalpy is basically delta H. Okay. We are having two types of enthalpy. One is lattice enthalpy of formation, and the other is lattice enthalpy of dissociation. Whenever we are studying about lattice enthalpy of formation, okay, basically lattice enthalpy of an ionic compound. Okay,
Right.
formation is an ionic compound. This is of ionic compound. So what is it? We are using some ions. That ions should be in gaseous state. Okay, that ions should be in gaseous state, and from that gaseous state ions we are making a compound that can be either solid, liquid, gas, that depends. Okay, so this is
Right.
called as lattice enthalpy of formation. So what definition we should write? This is called as formation. Okay, for an ionic compound I am writing. So we can write it for this one. 1 mole, you have to write this all. Okay, 1 mole of sodium chloride is formed from its gaseous ions. Okay, do remember always making of bond. Do remember, whenever we are making a bond, this is called as exothermic reaction. Always making of bond will be called as exothermic reaction. Always we call this as making of bond is called as an exothermic reaction. Always. Got it?
Right. Yes.
And for an exothermic reaction, you will be having delta H, minus in a minus sign. Let's suppose over here we have got an energy of minus 787, and we give it as kilojoules per mole. Getting my point?
Yes.
Okay. Now, the second one is lattice enthalpy of dissociation. Dissociation is basically breaking up of a molecule. Okay, as suppose I am having NaCl, this was in solid state. I
Right.
am breaking this up and I am making two ions from this. So what did I did? What I did, breaking of a molecule or a compound into gaseous ions. Okay. So what will we write for this one? We write a definition as energy absorbed. Now we need energy basically. Okay. Energy absorbed when 1 mole of ionic compound is broken up into its gaseous ions or gaseous states. Getting it?
Yes.
Okay. So these are basically what? These are the definitions of lattice energy. Okay, now moving on to the next definitions, you should be familiar with the some other definitions as we are having. Okay, as we are having some more definitions, that is, one is ionization energy. Okay, what is ionization energy? Whenever you want an an electron to be removed, okay, the energy
Yes.
which is required to remove an electron, okay, energy, we have done ionization energy, so you should be familiar. Ionization energy is the energy which is required energy required to remove electron from outermost shell when from isolated gaseous atom, from isolated gaseous atom. This is must. The atom which I remember when we did this one, I told you whenever you are going to remove an ion, that atom should be in gaseous state. Whenever you are making an
Yes.
atom into an ion, so we should have an atom into a gaseous state. We will be removing an ion that will be in this way, removal of one electron.
Right.
This is called as first ionization energy. Now, if we are having, we have to remove one more electron. So we will be writing this as Mg plus one electron. Just 1 second. Okay. Okay, now tell me one more thing. Which energy, okay, so we can write the definition over here. Okay. Energy, energy required to remove electron, we can write from outermost shell, okay, from isolated gaseous atom, okay. Okay, now tell me, do remember that whenever you are removing an electron, what will this be? This will be an endothermic or this will be an exothermic reaction? Yes.
It
If you
will
are
be endothermic
if you are removing, it will be an endothermic. Why? What is the reason?
because we're removing the electron.
Because we have to remove an energy, remove an electron, and for that we need a lot of energy. So do remember that ionization energy is always an endothermic reaction, because we need a force of attraction to remove an electron. Okay, we need a force of
Right.
attraction to break the bond. Okay, we need a force to break the attraction between what? Between the nucleus and the electron, isn't it?
Right.
So this is an endothermic reaction. Now, we also know that we are having ionization, electron affinity. What was electron affinity? What is electron
However,
affinity?
I think it goes from negatively charged, like neutral atom,
Electron
to negatively
affinity
charged.
is when we are adding an electron. Okay, when we are adding an electron. Ionization energy,
Right.
removal of electron, electron affinity, adding of electron. Okay, so electron affinity is what? When we are adding electron to gaseous atom. Okay, so this is called as what? This is called as electron affinity. Okay, do
Right.
remember that first ionization energy is always an exothermic. Okay, always an exothermic. First ionization energy. The first electron affinity. First electron affinity is always exothermic, because we are giving in the electron. So first is what? First electron affinity will always be nice. Okay, so what we were talking about, do remember that electron affinity, the first electron affinity is going to be always an exothermic. Okay, always an exothermic. But as you move on to second electron affinity, you move on to third electron affinity, you move on to fourth electron affinity. These all will always be an endothermic. Okay? Yes, Faiza, can you hear me better?
Yes. Actually,
Okay. So now we can write that first electron affinity, which we called it as delta HEA. We called it as delta HEA. Okay. The enthalpy change when 1 mole of electron is added to 1 mole of gaseous atom.